Okay, in this video, what we're going to do is create two simple commands. We're going to start out by creating the exit command, and then we're going to create the ls command. So Logan, let's go and get started with the exit command.
All right. Well, to begin with, let's test out our new command template and use it to add the command for exit. So I'll right-click on Commands, we'll add a new item, then we'll scroll down to My Templates and select a command template. Now for the actual name, this is going to be Command Exit. So we'll hit Add.
Now check this out. Class name, command exit. Public constructor, command exit. How convenient. Everything's already set up for us.
Right, the namespace is correct, and we have the proper name for the class already put in. As a matter of fact, we can build and the solution builds, so it's already set up as a working command.
Okay, now right here, before we forget, might even be a good idea to always do this at the beginning. Let's go ahead and register this command over in the command manager.
Right, because otherwise we'll just mysteriously not have it later.
That's right.
So let's jump into the command manager, and let's categorize this as a viewing command. In order to do that, I'm going to just kind of cheat a little bit and copy the existing line since most of it is the same. The two things that we need to change are the fact that the type of command this is a command exit, and the text we want to bind this to is the word exit.
Very nice.
So this will bind the text exit to an actual instance of an exit command.
All right, so let's go ahead and set up what exit does. And this is going to be interesting because we need to affect the while loop that's running all the way back in main.
All right, and right now we're just looking at the exit commands. That means what do we do when we're inside of exit? How do we cause the application to exit? Well, we actually need some supporting code in order to detect an exit scenario. So for the actual background to this, I'll begin in the command manager, and we'll set up the command manager so that it can check its own state and see when it is done running.
Okay.
In order to do that, what I'm going to do is make a public static field, a Boolean field called done, and I'll initialize it to false, even though that would be the default initializer. I'll explicitly show it just to make the code a little bit more clear.
So when the application starts, we're not done.
Exactly. Then we can take this value, turn around, go to the program file under the main method, and then replace this infinite loop with a condition. So we can say while not command manager dot done. So as long as the command manager is not done running, continue processing commands. And this gives us a value we can access in order to cause the loop to exit. Because if done is ever set to true, that means the command manager will stop running and the loop will stop running. That means back in the exit command we have something we can do here. We can set the command manager's done value to true, because we're done processing commands.
Simple enough.
We can even pull some of the lines closer together.
Actually, just in case somebody ran this application from a console to begin with, you could even set the output variable to say something like bye, or have a good day, or whatever.
Sure.
Because they would see a final closing message.
You say that the output is set to bye. We would see that on the command line if the command line was still open, and then we should be able to use that.
Looks good to me. All right, so the command's been registered. The class is set up. Let's go ahead and build, make sure all builds successfully, and it does. And let's go ahead and run it.
All right.
So let's clear everything. Oh, good, because that was indeed an invalid command, so we'll clear. Now let's try exiting. Ooh, fantastic. Let's go ahead and do one more thing as well. Let's set up the colon to indicate you're sitting at a prompt.
Sure, to make it feel a little bit more command-like. So let's jump back to program. And now inside of the command input loop, let's also do a console write.
Yeah, not a write line, because that would not give us the appropriate effect.
So we want to write out, we'll write out the string for just the colon character. Use something for a prompt character.
Okay, let's go ahead and run this.
So now it looks like we're sitting at a prompt. So if we do a clear, we're still sitting at a prompt.
Nice.
If we type in exit, then we exit.
Fantastic. Okay, so that's the exit command. Let's go ahead and create the ls command now so that we can get a listing of our nodes.
All right. So once again, back to the commands folder to add a new item. And once again, we'll use the command template. So we can change this to, let's see, a name for command for the ls command. Simply be command ls. We'll add that in. The template takes care of all of our naming. Now, what do we need to do inside of the list command? Well, for the simple version, we could do something like add an extra line in so that we space the results of this list off of any previous commands or lists. So we'll put in a simple write line just as spacing. So that's console write line, and then just write a blank line. Now, the list command, or ls command, is used for listing the scene. The simple version is to list everything at the root level. So that can be done by accessing our transform node and telling it to do a show all.
Right.
So we can say transform node dot show all, and that should provide a listing of the entire scene.
As a matter of fact, at this point we can go ahead and build, and let's make sure the command's registered.
So let's jump back to the command manager, and this is a viewing command. So let me copy one of the existing lines. And then we'll change the name or the type of class that we're instantiating to a command ls, and we want this to be bound to the text ls.
All right, and let's test it out.
So we're sitting at the prompt. If I hit ls, we get another listing.
Very nice.
So I can now clear, list again, and exit.
Excellent. So it's all starting to come together now. Now, we also specified when we first introduced you to this knowledge review that we wanted the ability to type in ls and specify a specific node anywhere within the hierarchy and get a listing of all of its children. Okay? So we need to set that up with the ls command here.
All right, that means we actually need to do a bit of detection on the given parameters, the given arguments. Because if no arguments are given, we still want it to work in the way that it shows everything. So just clear by itself will work as it was just shown. The difference is that we can say list from a given node, and then it will list from that. So we actually need an if condition to be put in place. And that condition will be put around this, because the show all is only one of the conditions. The check is going to be, how many arguments do we have? So we want to do a check and see if arguments is equal to 2. Because if we have just one argument, we just have the command.
That's right.
We should just show everything. If we have 2, then we have a node to list from.
Right.
So we can do if arguments dot length is equal to 2. If that's the case, we know where we're listing from. Otherwise, let me actually code in the else case, since we already have the body of that in place, which is the show all.
Okay. And if you guys want to take this further and account for there being 3 or more, then you could go ahead and set up an error that says you can only specify a single node if you're going to specify a node.
Right.
So, but once again, like I said, we're going to keep all the error checking simple. I'm just pointing that out. Okay, so now at this point, we need to look at a specific transform node. So we can't just call on transform node.showAll. So we're going to need to actually create just a real quick temporary transform node variable that we can find the given node. We've got to make sure it exists, and then we can call upon its show tree.
Exactly. That's the key there. We need to find a node, because right now, with the parameter we're looking at, we have the possible name of a node, just the textual name. We don't have an actual node yet.
That's right.
We need to use that name to look for a node, and then code in the proper cases for whether or not that node actually exists. So we can't type show, or excuse me, if we can't show ls for a node that doesn't exist.
That's right.
Now, what we want to do is we want to store a reference, a possible reference, to a transform node, because transform nodes are the only things that are going to be able to show. So this will be a transform node reference that we will call node. Now, in order to look this up, we want to set up a scenario where if found, if the node is found, it is stored in this variable. If it is not found, we want to make sure that node is null, and then we'll check the value of node itself. So in order to look for nodes, we can use the transform node find functionality, which takes in the string name. So we can pass in arguments 1, because of course arguments 0 is the command itself. Now here's the trick. Find is going to potentially find shape nodes, and shape nodes don't have any hierarchical information, and therefore one could not show a tree from one. So we need to put an additional filter, if you want to call it that, so that we only return transform nodes. We could do that with the as operator as a cast, because the as operator will return null if it was not the correct type. So we can cast as transform node, and what that'll do is we'll run the find. If the find finds a transform node, that's fine. We can cast it as a transform node and store that in node. If the find finds a shape node, we cast that as a transform node, it will return null, and null will be held in node. The same as if nothing was found from the find to begin with.
Exactly.
So that makes our check much more simplistic now. The check is simply to see if node is not equal to null. Because if it's not equal to null, we have an actual node we can deal with. If we have a real actual node, we can call upon its functionality, which includes show tree. And show tree is, of course, going to invoke the tree displaying functionality, but, of course, at the level of that specific node.
That's right. Otherwise, it wasn't found, so we could do else and set the output to...
Sure, give an actual error message for something like...
And we could say the argument not found.
So output equals invalid node specified?
Yeah, that works perfect. Good enough. Keep it simple.
And then go one step further from that, we could actually append to that, what was the node text? Argument 1. So we could append to that and say whatever was typed in was invalid.
Okay.
So at this point, we can build, make sure that we haven't introduced any errors, and everything is looking good, so we should be able to test. One quick usage of the simple way, clear by itself, or excuse me, ls. So ls, still showing everything. Now if we were to list from something like sphere, we should just see sphere by itself.
Actually, it's ls sphere.
Whoops. ls sphere. And there we go, it is actually working. If we tried to do ls and then some invalid name, invalid node specified, Z's.
Perfect. And since we've already tested out the show tree and we know that it works, we know that if we had other items parented to sphere, those would have been listed out as well. So beautiful. That pretty much covers everything we needed to do here for both the exit and the ls commands. Is there anything else you'd like to add to the slogan?
No, it seems to be working pretty well.
All right. Well, that's going to wrap up this video. Thanks.